everyone, so today we're going to go over lesson 6 of logarithms. So for this lesson, this is basically how to solve for x when x is in the exponent spot. So a lot of today's lesson is going to be very similar to steps we did before. So let's begin. So here, letter A, we see we have to solve for x, and x is in the exponent spot attached to 3. So whenever you see this happen, all you really need to do in this specific example is attach a log to both sides. And it's going to look like this. So it'll be log, and then in your bracket, 2 times 3x equals log 5. So all we're really doing here, again, is just attaching the word log to both sides. And then now from here, we see in our argument is multiplication. As I mentioned in our previous lesson, when you see multiplication, that means you're going to use multiplication law, and then you're going to have to do addition. So it's going to look like this. Log 2 plus log 3x equals log 5. And just as a reminder, we see 2 items in our argument, so we should have 2 different logs on the left side. Now at this stage, we have to see what can we do next. So we want to solve for x, and we can't solve for x when it's in the exponent slot, which it still is. So now I think, what can I do with the x in the exponent? And then after some thinking, you should realize, oh, I can move it to the front due to the power law. So now it's going to be log 2 plus x log 3 equals log 5. And then from here, we're just going to move everything to the right side and isolate for x. So x log 3 equals log 5 minus log 2. And now we just divide both sides by log 3. So x equals log 5 minus log 2 all over log 3. And when you plug this into your calculator, you should get 0.834, and it says round to 3 decimal places. So even on the exam, if they don't tell you how many decimal places to round to, it should always be 3. So I know I gave you the answer here, but I really highly recommend practicing it on your own, just to check over if you get the same answer. If you don't, that means you need to practice using brackets and getting used to your calculator. Because you could do all these steps right, but when it comes to plugging into your calculator, that's where a lot of students tend to have like a miscalculation. Anyway, so now we're going to go to letter B. So letter B is the exact same steps, except now our exponent has like a little equation in it. So all it really does is just adds a couple more steps. So here, we just add the word log to both sides. So log 19 x minus 5, and again just put brackets around your argument, equals log 3 x plus 2. And then now, right now, we don't have anything to multiply or no multiplication law, so we can look at our exponents and just bring them to the front. So you're going to take the whole exponent equation, not just the x, but the whole thing. And you have to include the brackets. It's super important. You'll lose half a mark if you don't have the brackets. So x minus 5 log 19 equals x plus 2 log 3. And now we're just going to FOIL or distribute. So it's going to be x log 19 minus 5 log 19 equals x log 3 plus 2 log 3. And now we're just going to bring all our x's to one side. So I'm going to move everything, all the x's to the left and everything else on the right. So x log 19 minus x log 3 equals 2 log 3 plus 5 log 19. And now we just get the greatest common factor, or aka just factor out x on the left side. So x log 19 minus log 3. And then same thing on the right. Or the right side stays the same, I mean. So 2, 5 log 19. And now our final step, or second last step before calculator, is we just divide the whole thing by the bracket. So x equals 2 log 3 plus 5 log 19 all over log 19 minus log 3. And then when we plug this in, you should get 9.166. And that's it for letter B. So now we're going to move on to letter C, and a lot of today's lesson is very repetitive. So here, some students ask, can we just attach the word log when it's a dot instead of a bracket this time? So you can. So here, if you see the dot between them, but this is realistically the same thing as 3, 5, 2x minus 1. They're the same thing. So you treat it the same procedure as we did earlier. So here, you get log 3. Oops, I forgot a bracket. 5, 2x minus 1 equals log 4x. That's a 4, not a 9. And now, we should do the same thing. We see multiplication law, so we just spread it out by using addition. So log 3 plus log 5, 2x, that should be a minus sign, minus 1 equals log 4x. And then now, we think, what can we do next? We see we have an exponent, and we don't want that, so we move the whole exponent to the front. So log 3 plus 2x minus 1 and log 5 equals log 4x. Oh, one of you is actually messaging right now. Kaylin, can you post the video? I need them for studying. So I'm just going to do a quick reply. I'm recording them right now. Anyway, so we're going to continue. So here, we just FOIL out the 2x minus 1. So everything else is the same. So plus 2x log 5 minus log 5. You could put the 1, but it'll be invisible. So I just tend to not put it. Equals log 4. And I forgot the x at the front here as well. So here, we see, what do we do next? We move all the x's to the same side. So I'm going to move all the x's, in this case, to the right side. Or actually, wait, no. Yeah. But yeah, I'm going to move to the right side, sorry. So log 3 minus log 5 equals x log 4 minus 2x log 5. It doesn't really matter which side you move the x's on. For me, the reason why I moved it to the right side is because both of my non-x terms are on the left side already. So I just took a second to think about it. But it doesn't really matter. You should get the same answer in the end. So then from here, we just factor out x. So the left side stays the same. Equals x and bracket log 4 minus 2 log 5. Do not factor out the 2 here because, well, you can't in the first place, but if you factor out 2, you end up having a bunch of different denominators and it's a lot more work, so don't do that. So here, we just divide the left side by the whole bracket. So now we have x equals log 3 minus log 5 over log 4 minus 2 log 5, and x equals 0.279. And that's your final answer for this question. So letter D. So here we have essentially the same thing, just extra practice. So it's going to be log, and in brackets, 3, 4, 2x plus 3 equals log 7, 4x minus 2. Don't forget your brackets. And then now we have two terms. That means we use addition law because they're being multiplied, and that means we should have two logs on the left side. So log 3 plus log 4 2x plus 3 equals log 7 4x minus 2. And now, what can we do next? We could move the exponents. So log 3 plus brackets 2x plus 3 log 4 equals 4x minus 2 log 7. So I'm going to write this in red of why you need to put the brackets. Because let's say I didn't put the brackets, I would do it like this, plus 2x plus 3 log 4. Then you have a random plus 2x here, and it'll make the whole equation complicated. But let's say you just fill this out anyway. Because you don't have brackets, this would actually make you get the wrong answers, and you'll lose extra marks because you're doing wrong mathematical procedures. So that's why it's super important to have brackets, because no matter where you go from there, you're just going to lose marks. Anyway, so we're going to continue. So here, we just FOIL it out. So log 3 plus 2x log 4 plus 3 log 4 equals 4x log 7 minus 2 log 7. And you guessed it, now we move all the x's to one side. So for this question, I am going to move it to the right side. So I have log 3 plus 3 log 4 plus 2 log 7. So I just moved this plus 7 over here. Equals 4x log 7 minus 2x log 4. And now we factor out the x. So again, for this question, do not factor out a 2 here, because even though in this one we see both of these coefficients have a multiplication of 2, don't do it because you're going to have to divide by 2 anyway, so it's just extra steps. Because again, we want x by itself. So if we could factor out x, it makes our whole procedure a lot easier. So your last step, well, I'm running out of room, so I'm just going to run on the side here. That you factored it out, it's going to be x 4 log 7 minus 2 log 4. So now we get log 3 plus 3 log 4 plus 2 log 7 all over this bracket here. So it's going to be 4 log 7 minus 2 log 4 equals x. And now x equals 1.826. And that's your final answer. So we're going to go over a quick lesson that isn't kind of related to these ones, but you will see this on exam. So this is called change of base. So on your calculators, if you press log, it will always just be the basic one where you have the little number as your 10, right? But here, you'll get asked on an exam, how do you evaluate log 205? So here, the little number is a 2, not a 10. So in order to do this, all you really do is you're just going to take both these numbers and have it as a fraction. You're going to have the word log on both the numerator and denominator. But for your numerator, you're going to take your base number, so the 5, and you're going to put the little number in the denominator. And that's it. So again, you just take the big number, numerator, small number, denominator. And then you just plug this into your calculator. So both of these have a base of a 10, that's just invisible here. But yeah. So now, if you plug this into your calculator, you'll get 2.322. And the same thing for letter B. This is going to be log 10 over log 3, which is going to be 2.096. So that's it for today's lesson, but I'm going to add one extra little example here that you will see on the exam as well, where they might ask you to estimate this instead. So when I see the word estimate, that means you won't have a calculator and you won't get the exact numbers. So they're going to ask you, if you had to guess or predict what this value would be, how would you do it? Show your work. So estimate log 25. Always try and figure out what would it approximately be. So how you're going to do this is, you're going to take exponents of 2. So 2 to the 1, 2 to the 2. You're going to continue. And you're just going to evaluate these. So 2 to the 1 is 2. 2 to the 2 is 4. And you're just going to keep going until you get one number that's going to be higher than 5. And one number that's going to be directly lower than it. So you're trying to find exactly where would 5 be between. So here we have 2 to the 1 is 2. 2 to the 2 is 4. 2 to the 3 is 8. So we see 4 is lower than 5, but 5 is smaller than 8. So 5 is going to be between these two numbers. So we know your exponent value, it's going to be a decimal, obviously, because there's no exact exponent where it would fit and make it equal to 5 exactly. So we just need to figure out what that decimal number is going to be. So here we check, is 5 closer to 4 or is 5 closer to 8? 5 is much closer to 4, so that means our decimal number should be lower than 5, but should be lower than 5. So you're going to say it's roughly around like 2.2-ish or 2.3. Any of those numbers would work. 2.4 is kind of pushing it. Do not put 2.5. But any of those numbers would be acceptable. And that would be your final answer. So here we see this is actually just 0.1 off. So that's how you know it's correct. But you would see this type of question on the exam. And this is how you would do it. Again, all the procedure is you just check for your exponent value which numbers would make it slightly above and slightly below it in terms of exponents. But that's it for today's lesson. Bye!